prove 3x plus 1 limit x go to 2 is 7. In high school, you just said, okay, 3 times 2 plus 1. This calculation is primary school. But prove this is 7 is not primary school. So here's the thing. We need to show what? We just show this sentence. For any disagreement from you, that means a gap. I prove that there exists a neighborhood. This means a neighborhood or a region of x near what? Near A. What's the A? A is exactly where my x need to go. This is what? There exists a region near A implies the f of those x near L. And near is measured by your gap. That's the idea. So I need to prove this, right? So what's my A? A is 2. Okay? So that's why I have x minus 2 here. And then what's my claim? My claim is fx minus L smaller than epsilon. I said work from the backward. So my fx is what? 3x plus 1. L is what? My L is 7. So I need this. So this first line is that we need to prove for all epsilon from U, there exists a delta larger than 0 such that if this is true, then this is true. So this means I want to prove this from here. What is this? 3x plus 1 minus 7. What I do? I can just what? Simplify the math, right? So what is this doing here? Plus 1 minus 7 means minus 6. So I have 3x minus 6. I can take out the 3, right? So I have this. So this is just simplifying an absolute value expression. Nothing new. Okay? And then, so I have this. But notice that I have this guy stay there, right? So actually, I also have this guy stay there, right? This part is exactly what I said here. We need 3 times this absolute value smaller than epsilon. Okay, then what? I just move the 3 to the other part. So it's the same as x minus 2 smaller than epsilon divided by 3. So this is what? Simplify the expression, further simplify the expression, and now we have simplified so much thing on this part. What we want to prove? We are going to prove that this will imply this, right? So then we look at this. X minus A is smaller than epsilon. What's my A? A is my 2. So therefore, I have the x minus 2 here. Okay? So what we have? We have this. And then here's the hardest part. What is this saying? This saying there exists a delta such that this implies this. That means we need to find this delta. In the sequence, it's the same. There exists an n such that for all the n larger than that big n, then this implies that. So this is the one we need to find. So in other words, this is disagreement from you. This whole thing is counter disagreement from me. I just show that there exists something that what you said is false. So this there exists part is the hardest part. So I need to find this delta. So because I have x minus 2 smaller than delta, I need to pick a delta such that this is true, right? Recall what I need. This sentence is this. I need to imply this sentence. What is this sentence? This sentence is the red on top, which is this thing. And I simplify to this, which is this. So I need from yellow to red. Look closely. How do I imply yellow to red? Almost looks the same. I just said, okay, now my delta is epsilon divided by 3, then done. Yeah, that's it. If my delta is epsilon divided by 3, so I have x minus 2 smaller than epsilon divided by 3, which is exactly this line, then done. So therefore, how do I prove this? You disagree with me saying that, oh no, this is false. There is a gap between this and 7 with an epsilon gap. Then I will say, no, for any gap you give me, I divide that gap by 3. Then this gives me a region in x such that what you said is false. And this is true for whatever gap you give me. So I have fight back all the disagreement from you. So therefore, this is how you read this. What I just did is 100% parallel to the sequence. Nothing changed. The only difference is that now this is not a sequence. This is a function. Sequence is what? Sequence is also a function. Let me recap. Sequence is what? It's a special function that the domain is a natural number to a real number. What I'm doing here for this 3x plus 1 is that now this n changed to real number. This guy is countable infinite. This guy is uncountable infinite. So the changes is in this part, okay? This part. But all the structure, all the logic, all the idea are the same. So this is how you prove this simple thing.